Hi everyone and welcome back to our last lesson of Activity 5. Today we are going to talk about a little bit more with solving our logarithmic equations this time. Now one thing that we must remember with these is when we are getting our final solutions, we must check those in the original logarithm because we need to make sure that it's not making our original logarithm negative because we are only able to take the logarithm of a positive number. And we may also want to start these off being sure that we condense before we are able to actually cancel out and actually solve, okay? Because one of the main properties we see, like our first example in the solving section, is that when we have a logarithm on each side, we are able to cancel out if they are the same base. So log base 8 on both sides allows us to cancel that out, and then we are just solving this equation here. Now, if we bring everything over to one side so that we have everything on the left-hand side this time, we have x squared minus x minus 14 equals 0. And this is a type 1 factoring. We have 1x squared, so we're looking at what multiplies to be negative 14, adds to be negative 5. Well, that is going to be negative 7 and positive 2. So when we factor this, we have x minus 7, x plus 2 equals 0. And then if we set each piece equal to 0, x minus 7 equals 0. So x is 7 when we add that over. X plus 2 equals 0. So x equals negative 2. Oops, and before we circle that, got a little crazy there, we want to double check, do these both work out? Because here's the thing, if we plug 7 back into the original, if I take 7 squared minus 14, I get a positive number. That's good. 5 times 7 on the other side of the equation. That's good. So when we plug it back into the originals, this worked out. However, when we plug in negative 2, so negative 2 squared minus 14, this does not work out, right? We get a negative value, negative 10. And then when we plug it into the right-hand side, we also get a negative number. And if any piece of this results in a negative logarithm, it is what we call an extraneous solution. And it's not going to work out. So extraneous. So it's not possible. All right, the next one, we are also going to look at these canceling out because they are both log base 11. And this time, if we set up our equation, we will need to bring over the 12 so that we are able to solve. So subtract over the 12. And same idea as last time, we are going to look at this factoring problem. We have 1x squared. So what multiplies to be negative 12 adds to be 4. That is going to be this time positive 6 and negative 2. Multiply to be negative 12, add to be 4. So x plus 6 and x minus 2 equals 0, our two factors. And then if we set each piece equal to 0 on this one, x plus 6 equals 0, subtract over the 6, x is negative 6, x minus 2 equals 0, add the 2 over, we get 2. So here's the thing. This time when we check these out, okay, and we look at we plug in, if we take that negative 6, so I know it's tempting to just cancel it out because it's negative, but if we take negative 6 squared and then plus 4 times negative 6, we end up getting positive 12. And when we look at the right-hand side, there wasn't actually anything to plug into. It's just 12. So this worked out to be positive 12. This is going to be an answer. And when we plug in our value of 2, we end up plugging this back in, 4 times 2. Plus 4 times 2. Big difference there. And we end up getting 12 as well. So both of these this time were able to be plugged back in and do in fact work out and are both answers. In part C, reminder, whenever we take an exponential to the log with the same base power, it ends up canceling out. And now we are just left with a quadratic to solve. So subtract over the x. Again, what multiplies this time to be negative 2 adds to be negative 1. Well, we're going to have negative 2 and positive 1 this time. So x minus 2, x plus 1, and then set each piece equal to 0. X minus 2 equals 0, so add the 2 over, we get 2. X plus 1 equals 0, subtract the 1 over, we get negative 1. Again, we have to double check though, in the original, right? If we plug this back in, would it make the logarithm negative? Well, 2 squared minus 2, that part is okay, right? If we plug in that first one, this one's going to work out, that's a positive, things are okay. However, if we take negative 1 squared and then minus 2, we get a negative 1 that would be inside. And that is not possible, right? We have to keep that log inside that parentheses piece positive in order for this to work out. Now in part D, okay, we have to be careful because unlike the problems in part A and part B, notice on this right-hand side there are 2 logarithms, right? And this goes back to what we talked about at the beginning here. Sometimes you have to condense before you can cancel this out. So let's bring these in to be one, or to condense on each side as much as possible. So I'm going to take log base 7 of x to the 1/2 power. And then on the right-hand side, we also have some log pieces that we can move back, 2 to the 4th power, and then log base 7 of 4. And we know that when we condense, this subtraction inside here actually is going to become division. Log base 7 of x to the 1/2, aka square root x, and then log base 7 of 2 to the 4th divided by 4. Now that these are condensed down to 1 log on each side, because we can only cancel 1 and 1, now we are actually able to set the square root of x equal to 2 to the 4th over 4. Now 2 to the 4th is 16. So right now we have 16 over 4, which is actually just going to simplify to be 4. So right now we have square root of x equals 4. And if we square both sides to undo the square root, we end up getting x equals 16. And when we plug 16 back in, that's a positive log still, so life is good. We are allowed to just call it x equals 16. All right, our next one, all right, we are going to, again, need to condense before we can cancel anything out. So we're going to condense on that left-hand side. This time we have log base 5, and then we have a minus 12. This plus sign means that we can multiply that by that other value, which is a plus 12. Now on this one, we'd only have a log on the left-hand side, right? There isn't one on the right-hand side that we are able to cancel it out with. The better option on this one is going to be to rewrite this log as an exponential, because if we rewrite this log, we would have a base of 5. Oops, write this different color. And that's going to be raised to the 2nd power, and it's going to equal a minus 12 and then a plus 12. Which, if we distribute this out, we end up with a squared plus 12a, and then we distribute the second piece, minus 12a minus 144. And from there, we can condense. We still have this 25 on this side. If we condense down, plus 12a minus 12a cancels out, so we have a squared. And then if we subtract over the 25, negative 144 minus 25 more is negative 169. Now from here, this is a difference of 2 squares, right? We have a squared is a squared, 13 squared is 169, and then since it's a difference of 2 squares, one of these is positive, one of these is negative. Now again, when it comes to actually looking at our values of a, they are either going to be positive 13 or negative 13 when we plug them back in. Well, in the original, if I plug in positive 13, this stays positive because it becomes 1. This stays positive, it becomes 25. So this one's okay. However, when I plug in negative 13 to the original part, this creates a negative logarithm both there and in this second part. So doubly does not work, and only a equals 13 works out. All right, now the next one is very similar to the last one. The first thing, you want to rewrite this so that you condense the left-hand side. And then from there, you want to make sure you solve to make sure that you get the values for x. Remember to check for an extraneous solution. All right, down at the bottom, we have a couple more examples for you. This one, we are starting off with ln. So reminder, ln is the same thing as saying log with the base of e. And similar to what we did up above, we are able to rewrite this as an exponential because the base of my logarithm is the base of my exponential to the third power equals that piece in parentheses. Now, e to the third power is a value we can get from our calculators, and we are going to subtract from that to get x by itself, 3. And then we still have 2x, so to get x completely alone, we can divide all that by 2. So I'm going to take e to the third power, and I'm going to subtract away from it 3, and then, e to the third power, subtract from it, outside of the parentheses, 3. And then I'm going to divide that value by 2 to get x completely alone, and I get about 8.543 for my value of x. On the last one, we also need to condense to start. Notice there's 2 ln's on the left-hand side. We can combine those two using some division. Now on this particular problem, then once we get these ln's condensed, there's 1 on each side that we can just cancel out. So we have x minus 3 divided by 2 equals 15. Both sides get multiplied by 2. X minus 3 equals 30. Add the 3 over to get our final answer. Now we want to double check if we plug this back in where we see an x in the original log. Are we good to go? The answer is yes. Worked out for us. All right. Thanks everyone for watching. We'll work more with these lots in class.